Richard Almario from 10 Blissfulness. My report is all about the network cables and their advantages and disadvantages. To start with, let me tell you the classification of network cables. Network cables are classified into three, namely twisted pair, coaxial, and optical fiber. First, I will discuss twisted pair cable. Twisted pair cables consist of color-coded pairs of insulated copper wires. One wire carries the signal and the other is used for ground reference. Every two wires are twisted around each other to form pairs that are encased in plastic sheet, each wire with a diameter of 0.4 mm to 0.8 mm. Twisted pair cables have two types. First, shielded twisted cable, STP. Second, unshielded twisted pair cable, UTP. Shielded twisted pair cable, STP. As the name implies, shielded twisted pair cable adds a conductive layer, typically a metal foil or a mesh, surrounding either each pair of intercable. Purpose: shield on twisted pair allows a higher transmission rate. Advantages: easy installation. Second, it has a higher capacity as compared to UTP cable. It is shielded that provides a higher data transmission rate. Disadvantages: cables are bigger in diameter, more expensive compared to UTP or coaxial cable. Next, the second type of twisted pair cable, unshielded twisted pair cable. Unshielded twisted pair cable uses no additional shielding like a mesh or aluminum foil, which adds bulk or use. These are the different types of unshielded twisted pair cable. All support different bandwidths. Category 1 is used for telephone line that has a low speed data rate. Category 2, it can support up to 4 Mbps. Category 3, it can support up to 16 Mbps. Category 4, it can support up to 20 Mbps. Category 5, it can support up to 200 Mbps. Purpose: untwisted pair cable is used for voice, low speed, and high speed data audio support systems. Advantages: it is cheap compared to coaxial or optic fiber cable. Used in computer networking such as Ethernet for short to medium distances. Disadvantages: this cable can be used for shorter distances because of the signal attenuation. The second type of network cable is coaxial cable. Coaxial cables are also called hooks. Coaxial cable is a type of cable with multiple layers. Coaxial cables have an inner conductor is called the core, which carries the radio frequency signal. The core wire may be a single solid conductor or multi strands of twisted cable. It's surrounded by an electric insulator. The dielectric insulator separates the inner conductor and outer copper braided mesh. The dielectric insulator may be polyethylene foam or PTFE, which minimizes ohmic losses arising from contact with the conductors. Outer jacket is to protect the cable from environmental and mechanical damages. A common choice is PVC. Both inner conductor and braided wire mesh conductor is in the cable share a common central axial, hence the term of coaxial. Coaxial cables are rated in ohms for their impedance. Common impedances are 50 ohms, 75 ohms, 95 ohms. There are many types of coaxial cable connectors. 4 are common: BNC, SMA, and F types. Coaxial cables are categorized based on the type of signal transmission. One is baseband and the other is broadband cable. Baseband cable. It is 50 ohms resistance cable that is capable of digital transmission, used in short distances for optimum performance. Broadband cable. It is a 75 ohms resistance cable used for analog data transmission. It uses up to 100 km. Based on radio gauge, standards are two types of coaxial cables. These are the types of coaxial cables: thicknet and T-net. Thicknet RG8, RG9, RG11 coaxial cable is also known as thick Ethernet or 10 base 5 systems. 10 means it is 10 Mbps speed and 5 refers to 500 meters distant between nodes or repeaters. Where base indicates that the transmission type is baseband transmission. Thicknet cabling uses heavier gauge coaxial cable than T-net. T-net RG58 coaxial cable is used 10 base 2 systems. 10 means 10 Mbps speed and 2 refers to 200 meters distance between nodes or repeaters. Advantages: coaxial cable is used for both analog and digital data transmission. It has a higher bandwidth, so it supports a mixed range of services. Relatively less expensive compared to fiber optic cable. Disadvantages: the number of node connections is limited, prone to damage due to lightning strikes. The last type of network cable is optical fiber cable. It is also known as fiber optic cable, consists of strands and of one or more fibers inside the casing. Its assembly is similar to electrical cable. Optical fiber cable has three parts. Core. It is the inner layer is called the core with the refractive index N1. Light is guided in this part. The core will have a higher refractive index than cladding. Second, cladding, which runs the core with refractive index N2, whose refractive index is less than the core. The purpose of cladding is to keep the light reflection in core instead of being reflections. Casing, which is an outer layer for protecting the cable damages. There are two types of optical fibers, glass and plastic. Plastic fiber is used for short communication. Optical fiber transfers data at the speed of light in the glass. Optical fiber cable use light pulses instead of electrical pulses to transmit data. The potential hazard of infrared red light used in telecommunication cannot be seen by the naked eye. Optical fiber cable comes in a single mode or multi-mode connections. Single mode. The single mode allows only one mode of light to transmit at a time through the core, which makes for higher bandwidth. Single mode fiber optic, the number of light reflection in the core is less, resulting in low attenuation and allowing data to travel further faster. Single mode provides the lowest losses in communication. Multimode. Multimode connections have a larger core diameter. It allows multiple wavelengths of light transmitted in multiple paths at once. Multimode connections are used over shorter distances as signal attenuation will be more. The data transfer rate is slow as a number of reflections in the core are more. Advantages: extremely high bandwidth or speed. Impervious to electromagnetic interference. Several kilometers of optical fiber cable can be made cheaper than the equivalent length of copper cable. Optical fiber usually have a longer life cycle for more than 100 years. The loss of signal in fiber optic cable is very less than that in copper wire. The smaller size and lightweight than a comparable copper wire cable. Less weight can be bundled together. Optical fiber is thinner and can be drawn to smaller diameters than copper wire. Disadvantages: More unsafe than damage compared to copper wires. Should not twist or bend the fiber optic cables too tightly. Follows specification for cable band radius. That's all. Thank you for listening.